Hello, Concord Junior High. Welcome to another math video by Mr. Rock. And in this video, you will learn how to use the slope-intercept equation, also known as y equals mx plus b, to make a graph. You will also learn how to write a linear equation from a graph. And you will learn how to use a point and the slope to write an equation. And you will learn how to use 2 points to write an equation. And you will learn how to rewrite a linear equation into slope-intercept form. That's a lot to learn in one video. Let's get started. This is the slope-intercept equation. It looks like alphabet soup. What do these variables mean? Well, first of all, the x and the y. These variables are ordered pairs. So the x and the y, they're ordered pairs that stand in the place of all numerical ordered pairs that are solutions of the equation. So the x and the y, those are ordered pairs that are solutions of the equation. M right here, that is the slope. And B is the y-intercept. So this is called the slope-intercept equation. Y equals mx plus b. Now let's learn how to use this equation to make a graph. The directions say graph. Y equals -2/5 x plus 4. This is the x and this is the y. Those variables represent all numerical ordered pairs that are solutions of the equation. This right here is the y-intercept. We are given that the y-intercept is equal to 4. So I am ready to plot my first ordered pair. My first ordered pair goes right there. That is the y-intercept. Next, this is the slope. The slope is -2/5. Remember, the slope is the rise over the run. So from the y-intercept, I'm going to use the slope, and I'm going to think about it as the rise over the run. So the numerator is the change in y. So I'm going to start here, and it's the rise. The rise is -2. So I'm going to go down 1. I'm going to go down 2. This is the run. This is the change in x. So I go down 1, 2, and I go over 5. 1, 2, 3, 4, 5. So my second ordered pair goes right there. So I'm going to go down 2, and I'm going to go over 5. So that's my second ordered pair right there. And now I have the minimum number of points needed to graph a line. That's 2. So all I have to do is connect these 2 points with a straight line. So your graph is going to look something like this. Now let's go over how we did this one more time. First of all, this equation is in slope-intercept form. It's y equals mx plus b. We are given that b equals 4. And that's where we draw our first point, the y-intercept. B equals 4 right there. Then we are given the slope. The slope is negative 2/5. So from this spot right here, we go down 2 and over 5. And we get our second point right there. So we get our second point by using the slope. We get our first point with the y-intercept, and we get our second point, and I should probably write down m equals negative 2/5. We get our second point using the slope. That's all there is to it. If you have any questions about how to do this, rewind the video and watch this part again. Here's another example of how to graph. We have y equals negative 3/4 x. Wait a minute. This equation is missing something. I see that it has an x. I see that it has a y. And I see that it has a slope. But it's missing the y-intercept. Oh no, what do we do? Well, this is how we can add the y-intercept to the equation. It's going to be pretty sneaky. A sneaky snake. All we're going to do is add 0. Right, adding 0 to a quantity doesn't change its values, so you can add 0 as much as you want. I add $0 to my bank account, and it doesn't change. All right, so I have my y-intercept. Now I'm ready to graph. Here we go. The y-intercept, b, equals 0. It looks like a 6. Now it looks like a 0. Y equals 0 is right there. The slope is negative 3/4. So from the y-intercept, I go down 3 and I go over 4. And I get my second ordered pair. Now I have 2 points and I can graph. This is y equals negative 3/4 x. Pretty nice. This is pretty nice technique for graphing, isn't it? This slope-intercept technique for graphing. It's a lot easier than making a table. Remember making a table for functions earlier this year? Well, we have to do that with more complicated equations. But for these equations, we can get away with using this form. Here's another example. And uh-oh, this equation looks like it's missing some stuff too. I see an x and I see a y, but it appears to be missing the slope, and it appears to be missing the y-intercept. Well, I know how to fix the y-intercept. All I have to do is add 0. Now I have a y-intercept. But now the question is, what is the slope? There's no number there. Well, there is a number there. It's just invisible. And that invisible number is 1. You can think of that as negative 1 times x. And wait a minute. Slope is supposed to have a rise over a run. That just has a rise. Well, you can fix that problem too. You can change any integer into a fraction just by placing a 1 in the denominator. Now I have a rise over the run. Now we're ready to graph. So the y-intercept is 0. The y-intercept is right there at 0. So I should probably write this down. B equals 0. M is the slope. The slope, we just figured out, was invisible, but we made it visible, is negative 1 over 1. So that means from the y-intercept, we go down 1 over 1, and we have our second point. By the way, if we keep using the slope over and over, we get more solutions. You can keep using it over and over as much as you want. And you can use it in the other direction too. You could go up 1 to the back 1, up 1 to the left 1, I should probably say. Up 1 to the left 1. Look at that. It looks like a staircase. Let's connect all these points with a straight line. Oh my goodness. Kind of sloppy. But it works. That's the graph of the equation y equals negative x. Something that's important to understand. Something that's important to understand is that all of these points, okay, those are represented by the x and the y. Okay, for example, this right here, this point. X is 4, y is negative 4. Okay, so let's write that down. If I can write it down neatly. So we have 4, negative 4. Okay, remember I said that the x and y's represent all numerical solutions. This is just one numerical solution. Let's put it into the equation to see if it works. I have y equals negative x. Let's see, x is equal to 4. Y is negative, look at that. Negative 4 equals negative 4. See how that works? So again, I'm trying to emphasize that every ordered pair, numerical ordered pair, is represented by the variables x, y. Beep, 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 beep. You know what that sound is? That's the sound of a truck going in reverse. And the reason I'm making that noise is because we are going to do the reverse of what we just did. We just started with the equation and made the graph. This time, we are going to start with the graph and write the equation. So it's reverse. So the first thing I'm going to do is I'm going to write down the equation. Y equals mx plus b. There are only two numbers that I need. I need to know what b is, and I need to know what m is. Those are the only two numbers I need to figure out from the graph. And all I have to do is use my eyeballs to figure it out. So I'm looking at the graph, and I'm going to see where it crosses the y-axis. I'm moving. This is a nice negative slope, by the way. I'm going down. Bam! Right there. Negative 1. So b is negative 1. I'm going to write that down over here. B is negative 1. Again, all I had to do is use my eyeballs to figure that out. Now, for the slope. For the slope, I need 2 ordered pairs. Okay, and I want to pick ordered pairs that go through lattice points. And this is what I mean by lattice point. A lattice point is here. A lattice point is here. A lattice point is here. It's where the vertical lines intersect the horizontal lines. Okay, those are whole numbered ordered pairs or lattice points. So, as I take a look at this, here's a lattice point right there. I keep sliding down. Here's a lattice point. I keep sliding down. Here's a lattice point. Keep sliding. Here's one. Here's one. There are lots of lattice points to choose from. I only need to pick 2. So I'm going to pick 2. It doesn't matter which 2, just pick 2. So I'm going to pick one here. That's a lattice point. And I'm going to pick one here. That's a lattice point. All right, so I picked my lattice points. Now, what I'm going to do is make a right triangle using those lattice points. So let's see. There's one part of the right triangle. That would be the vertical change. And here's the horizontal change. Okay, so and I'm going to count. Okay, I'm going to count. This is 1, this is 2. And this is just 1. Okay, so this is how you calculate the slope, right? Remember when we calculated the slope from a graph? Well, that's exactly what we're doing here. So we've seen this before. So the slope is 2 over 1. Negative 2 over 1, because it's a nice negative. Or you can just say it's negative 2. So the equation then is y equals the slope, which is negative 2x, plus the y-intercept, which is plus negative 1, or just minus 1. It's up to you how you want to finish it. That's it. That's how you write an equation from a graph. Okay, in all the examples we've had so far, they have used a graph. So you get to see what's happening when you use a graph. Well, this problem here, there isn't a graph. This problem here is going to be all algebra. So here are the directions. It says write an equation for a line that goes through the point 2, negative 3, and slope is negative 4. All right, well, what do we need to do? We need to write an equation, and the equation that we are going to write is going to be a slope-intercept equation. So it's going to be y equals mx plus b. So I need to figure out 2 numbers. I need to figure out m, and I need to figure out b. Well, lucky for me, lucky for us, they tell us in the problem that the slope is negative 4. So I know what m is. So I'm going to change that question mark to negative 4. So I know the slope is negative 4. When I go back and I reread this statement, it doesn't tell me anything about the y-intercept. How am I going to figure out the y-intercept? They don't tell me what it is. They give me an ordered pair, and they give me the slope, but they don't tell me the y-intercept. So this is something that I'm going to have to calculate using the information that they have given me. All right. So I have an ordered pair that they gave me. So let's write down that information. I know that x equals 2 and y equals negative 3. wait a minute. I know what I can do. I can use all of this information that I have here, and I can plug it into this equation that I have here, and I will have only one unknown, which is b, and then I can solve for b. That's got to be it. All right, so let's try it. So let's see, y is -3, m is -4, x is 2, plus b. See, -4 times 2 is -8. So I have -3 equals -8 plus b. I know how to solve this. This is easy. Plus 8 plus 8. And I get b equals 5. Oh, but we're not done yet because we're supposed to write an equation. All right, so the equation is y equals the slope. The slope is -4x, and b is 5. Look at that. You're going to have lots of problems like this on your assignment, so you may have to watch this example more than one time to figure out what's going on. But okay, here's another problem. Ooh, it looks like we get to write an equation for the line that goes through the points 3, 2, and 2, -2. All right, my equation is y equals mx plus b. So I need to know two things. I need to know what m is, and I need to know what b is. This problem is kind of like the last one, but I bet it's going to be different. All right, so let's reread the problem, see if we can figure out what m and b are. So it says write an equation for the line that goes through the points 3, 2, and 2, -2. Well, they don't give me the slope, and they also don't give me the y-intercept. And it looks like I'm going to have to figure these things out algebraically. I know how to calculate the slope given two ordered pairs, right? Let's see. I can write this down. M equals y2 minus y1 over x2 minus x1. Okay, I can figure out the slope. M equals, let's see, up here, y2 is -2 minus, all right, y1 is 2 over x2. x2 is right here. x2 is 2 minus x1 is 3. All right. So -2 minus 2 is -4. 2 minus 3 is -1. So the slope then is equal to +4. All right, so I figured that much out. So I'm going to change this up here, and I'm going to cross out that. I'm going to put in 4. The slope is 4. Okay, next we're ready to calculate the y-intercept. So just like in the last problem, I need to use an ordered pair. So I'm going to use the fact that, I'm going to use the first ordered pair, x equals 3 and y equals 2. You can use either ordered pair for this. It doesn't matter. All right, so I'm going to use this information in my slope-intercept equation. So y is equal to 2. M, I just calculated, is equal to 4. X is equal to 3 plus b. 4 times 3 is 12. Minus 12 from both sides. And I get b equals negative 10. So I'm going to come back up here. I'm going to cross that out, and I'm going to write in negative 10. So now I'm finally ready to write the equation. Y equals 4x plus negative 10. A lot of steps, but it's definitely doable. That's how you take two ordered pairs and write an equation. You may have to watch this video more than once. Take notes. You can learn how to do it. Almost finished. This is a long video. All right. So this one says, write the equation 3x plus 6y equals 2 in slope-intercept form. So what they're asking me is they're asking me to take this equation and rewrite it so that it's arranged y equals mx plus b. That's what they want. Why do they want that? Well, it's easy to work with equations in slope-intercept form. They're easy to graph. All you have to do is, pick out the y-intercept and then use the slope to get your second point. So, yeah. Anyway, so all right. So let's take this equation. 3x plus 6y equals 2. And the first thing I'm going to do is I'm going to subtract 3x from both sides. So it's going to look a little weird. Okay, I get that. And what I get here is 3x minus 3x, and that much is going to be 0. Okay, so I get 6y over here equals, let's see, I want my mx next. My mx is minus 3x. And then that's my y-intercept plus 2. So you can see in one move, we've made a lot of progress. This equation's getting closer to slope-intercept form. There's one more thing we need to do. We need to divide everything by 6. So what do we get here? We get 6 divided by 6, which is just 1. 1 times y is y. What do we get here? We get negative 3x divided by 6, which is negative 1/2 x after reducing. And here, plus 2 over 6 reduced down to 1/3. Is this in slope-intercept form? Let's see. Y, slope, x, y-intercept, y-intercept. We did it. Something to keep in mind is that this equation here in slope-intercept form is the exact same equation as this up here. Ooh, this is written in standard form. Okay, these two equations are equivalent. They may look different. This one's in slope-intercept form. This one is in standard form. They may look different, but they're exactly the same. All we did is rearrange the equation. That's all we did. Oh, here's another one. Write this equation in slope-intercept form. Okay. Y equals mx plus b. The equation is 2y equals x plus 8. Oh, this is going to be done in one step. This is one step. All we have to do is divide everything by 2. Look at that. We get y equals 1/2 x plus 4. Beautiful. Easy. So we took this equation here, not written in slope-intercept form, and we rewrote it into slope-intercept form right here. Beautiful. You know, another reason you need this skill, it's for graphing equations with technology. A lot of technology, not all technology, but some technology, I should say, requires an equation to be graphed. It requires the equation to begin with y. One more example. All right, here we go. Convert the equation to slope-intercept form. 8x minus 4y equals 20 equals 0, plus 20 equals 0. All right, fine. Let's use a different color. Y equals mx plus b. And I have 8x minus 4y plus 20 equals 0. I think the first thing I'm going to do is I'm going to minus 8x from both sides. So I get, be careful, this much is 0. And this is what I mean by being careful. This minus 4y, think of it as adding a negative 4y. So you get negative 4y plus 20 equals negative 8x. All right, next step. We're going to subtract 20 from both sides. So we get negative 4y equals negative 8x minus 20. Getting closer to slope-intercept form. One more step to go. Divide everything by negative 4. And we get y equals, what's negative 8 divided by negative 4? That's 2. There should be negative. And what's negative 20 divided by negative 4? That's 5. So we've taken this equation, not written in any particular form, and we rewrote it in slope-intercept form. Again, keep in mind that these two equations are equivalent. They're not identical because they obviously look different, but they are equivalent. We just rewrote it to a more convenient form. Oh my goodness, that was a long video. So in this video, I hope that you learned about the slope-intercept form of an equation, y equals mx plus b. X and y, they are variables that represent all the numerical ordered pairs. M is the slope, and b is the y-intercept. And I hope that you learned how to graph an equation written in slope-intercept form. Start with the y-intercept, then use the slope to get the second point, and that's all you need to graph. I also hope you learned how to write an equation from a graph. You start with identifying the y-intercept, and then finding another lattice point, make a triangle, and count to calculate the slope. I hope you learned how to write an equation using the slope and a point. And I hope you learned how to write an equation using 2 points. And I hope you learned how to write an equation not in slope-intercept form, into slope-intercept form. Oh boy, long video, lots to learn. You're going to have to watch this more than once. Good luck. Hope you learned a lot.